Before we talk about the announcement, it is essential to comprehend what particle accelerators are. The Large Hadron Collider, LHC, run by CERN, is a superconductive magnet ring with a length of 17 kilometers and is the most powerful and largest particle accelerator. It represents humanity's most significant scientific achievement, sufficient to replicate the circumstances at the start of the universe. But might this device be used to gain access to something significantly more dreadful? The key lies within the secrets of the universe. CERN, founded in 1954, is regarded as one of the best research institutions in the world. With 23 member nations and thousands of scientists, CERN serves as a central location for cooperation and innovation, exemplified by the LHC undertaking. But it's just one part of an extensive system of accelerators and experiments. Imagine a racetrack, not for horses or automobiles, but for subatomic particles, scurrying at nearly the speed of light. Protons are accelerated in a vacuum at speeds comparable to light, sending them into high-energy collisions that resemble the large-scale conditions of the Big Bang. These collisions generate temperatures millions of times hotter, thousands more than the core of the Sun. Superconducting magnets guide the protons, and intricate cooling systems keep temperatures lower than outer space. The beams inside the LHC collide at 4 important locations around the accelerator ring, aligned with 4 particle detectors: ATLAS, CMS, ALICE, and LHCb. Each serves a distinct purpose in studying various aspects of particle physics. These detectors, enormous cameras, capture images of these collisions. Scientists then sift through the resulting data, looking for evidence of mysterious particles like the Higgs boson, the God particle, and other fundamental building blocks of the universe. By studying the microcosm, we gain an understanding of the macrocosm. However, with each new answer, new questions arise, each discovery presenting a new frontier. The LHC is more than just a scientific instrument. It is evidence of innovation and human curiosity, exemplifying our unwavering pursuit of knowledge and the need to comprehend the fundamental factors that shape our universe. But as we press the boundaries of what we know, we must also think about the moral and existential questions that arise regarding the dangers of the unknown. What are the risks of exploring the unknown? Could our search for understanding inadvertently unlock forces that are beyond our control? Within the prestigious halls of CERN, where the limits of human comprehension are frequently questioned, a shocking new revelation has emerged, one that perturbs even the most experienced scientists. Brian Cox, a former researcher at CERN and a respected authority in particle physics, recently made comments that resonated with audiences, both enthralling and terrifying them. Cox revealed that the LHC's objective is to recreate a miniature Big Bang. That's right, a miniature version of the very event that gave birth to our universe. He further explained the implications of this goal, highlighting the LHC's potential to decipher the mysteries of the Higgs boson, explore dark matter, and expose additional fundamental secrets of the universe. Imagine possessing the power to conjure the very essence of the universe. It's a tempting but risky option. This miniature Big Bang is not just a theoretical idea. Within the LHC, it is an observable fact. The temperatures, pressures, and raw energy generated mimic the conditions of the universe's infancy, as if we are standing at the dawn of time itself. But with such enormous influence comes enormous responsibility. One terrifying incident that underscores these dangers is the case of Anatoly Bugorsky. In 1978, Anatoly Bugorsky, a Russian physicist, experienced a horrific accident that changed his life forever. While utilizing the U-70 synchrotron at the Institute of High Energy Physics in Russia, a flaw resulted in his head accidentally coming into contact with a direct proton beam. The beam, carrying a force unimaginable, entered the back of his skull, passed through his brain, and exited through his nose. Bugorsky later said he saw a flash brighter than 1,000 suns, yet he felt no pain. The beam blazed a destructive path through his bone and tissue, yet he remained conscious, even walking to a medical facility for treatment. The consequences were both fascinating and horrifying. The beam's precise path caused widespread destruction of tissue, partial facial paralysis, and remarkable hearing loss in one ear. Yet his intelligence remained intact, and he continued his work as a scientist. Bugorsky's incident is not just a standalone tragedy, it serves as a warning about the immense power and potential dangers posed by particle accelerators. This increases the fear of creating a black hole. Particle accelerators like the LHC are not to be underestimated. One of the most alarming and controversial concerns about the LHC is the potential to create a miniature black hole. A black hole is a region of spacetime with such a strong gravitational pull that not even light can escape. These cosmic vacuum cleaners devour entire stars and lurk in the shadows of the universe. The belief that the LHC could produce such an entity, even at the smallest scale, shocked both the general public and scientists alike. Some fear that a black hole formed at the LHC could grow out of control, eventually consuming the Earth. However, CERN researchers reassure the public that any black hole created would be extremely unstable, lasting only a fraction of a second before evaporating. Despite this, the mere possibility has sparked controversy, fear, and wonder. The idea of the LHC creating a black hole hinges on the fundamentals of particle physics. At close range, when protons collide at immense speeds, the energy released is so immense that it can alter the space-time fabric itself. Imagine a trampoline stretched tightly. Place a heavy object on it, and the fabric stretches, creating a deep well. In terms of gravity, if the weight is heavy enough, it could create a depression so severe that nearby objects are drawn into it. This is a simplified illustration of what might happen inside the LHC. Yet, as with any significant scientific advancement, the pursuit of knowledge carries a dual edge. The very tools that allow us to peer deeper into the workings of the cosmos also brush up against realms we scarcely comprehend. The Large Hadron Collider, LHC, embodies this paradox, a beacon of human ingenuity, but also a humbling reminder of how little we truly command the universe's hidden forces. Despite extensive safety reviews, theoretical assurances, and the careful stewardship by the world's most brilliant minds, the unknown remains, vast and unpredictable. In a universe governed by quantum uncertainty and dimensions perhaps hidden beyond our senses, there will always be risks that cannot be entirely eliminated, only mitigated. This is not a call to halt progress. Rather, it is an invitation to respect it. To move forward with a balance of courage and caution, driven not by fear, but by a profound reverence for the forces we seek to understand. At CERN, the atmosphere is one of awe and responsibility. Scientists working within those corridors know that their work could answer some of humanity's oldest questions. What are we made of? Why does the universe exist? Are there other realms, other versions of reality beyond our own? Each collision, each fleeting particle born from unimaginable energies, each burst of data recorded by Atlas, CMS, ALICE, and LHCb, brings us closer to peeling back another layer of the cosmic onion. Yet with every new discovery, new mysteries emerge, some beautiful, others unsettling. And so, the world watches. Some with admiration. Others with trepidation. Many with a mixture of both. Because when we smash protons together at near-light speeds, we are not just exploring the minute, we are challenging the very foundations of existence. We are standing at the precipice of creation itself, reaching into the void with a trembling, yet determined hand. Perhaps one day, thanks to the bravery of these endeavors, we will finally comprehend the grand design of the cosmos. Perhaps we will learn that existence is far more intricate, far more interconnected than we ever dreamed. Or perhaps we will come to realize that some doors, once opened, can never be closed again. Regardless of what awaits, one thing is certain. The story of the LHC is not just a tale of science, it is a chapter in the eternal human saga of discovery, wonder, and the relentless quest to find our place among the stars. With risks, the key is to approach such advancements with a mixture of wonder, respect, and caution. The Large Hadron Collider represents the cutting edge of scientific exploration, where theoretical physics meets experimentation. Its ability to address fundamental questions, such as the origins of mass and the nature of dark matter, is unparalleled. Yet, despite strict safety measures and precise calculations, the LHC continues to spark curiosity and, at times, concern. Despite these concerns, the overwhelming consensus among physicists is that the LHC is safe. The natural universe itself provides a compelling argument for this. Cosmic rays, high-energy particles from space, regularly collide with Earth's atmosphere at energies far exceeding those produced in the LHC. If dangerous phenomena, such as vacuum decay or miniature black holes, were a real threat, they would likely have occurred naturally in the universe long before human-made experiments ever had the chance to trigger them. Moreover, CERN has repeatedly conducted extensive safety assessments, reviewed by independent scientists worldwide. Each time, the conclusion remains the same: there is no credible risk posed by the LHC's operations. Theories that suggest catastrophic scenarios, while intriguing in a theoretical sense, lack experimental support and remain within the realm of speculation. Even so, science thrives on skepticism and inquiry. The fears surrounding high-energy physics experiments stem from the broader human tendency to fear the unknown. History has shown that every great scientific breakthrough, whether it was the discovery of nuclear energy, the development of artificial intelligence, or even the first spaceflight, was met with initial trepidation. But science advances by pushing boundaries, and it is through calculated risk and careful study that humanity has continually expanded its understanding of the cosmos. The LHC represents one of the most ambitious scientific endeavors in history. It has already led to groundbreaking discoveries, such as the confirmation of the Higgs boson, which has helped physicists refine their understanding of the fundamental forces governing the universe. Looking ahead, the Collider's future experiments could provide deeper insights into dark matter, antimatter, and even the early moments of the universe itself. Yet, as with all powerful tools, responsibility is key. Scientists at CERN acknowledge their duty to both scientific progress and public safety. They understand the weight of their work not just in terms of knowledge gained but also in addressing public concerns. The balance between curiosity and caution is what defines the pursuit of truth in science. In the end, the Large Hadron Collider is not a doomsday machine, nor is it a gateway to otherworldly dimensions. It is a monument to human curiosity, a device designed not to destroy, but to explore the very fabric of reality. Whether it uncovers hidden dimensions, deepens our understanding of particle physics, or simply raises new questions, one thing is certain: its impact on science and humanity's quest for knowledge will be felt for generations to come. A feeling of uncertainty and mystery lingers among some. The sheer scale of the machine and the energy it generates is awe-inspiring, and every new experiment opens the door to uncharted scientific territory. While most scientists remain confident in the safety of LHC experiments, there are unanswered questions. What if unforeseen events occur, challenging our understanding of physics and the universe's laws? The LHC pushes the limits of human knowledge and questions our control over the natural world. As particle collisions recreate conditions not seen since the Big Bang, the profound nature of these experiments raises existential questions about the potential consequences of manipulating the very fabric of the universe. Despite the LHC's achievements in particle physics, which have been transformative, it has led to the discovery of the Higgs boson, advanced our understanding of the Standard Model, and opened pathways to potential breakthroughs that could reshape our technological future. Yet risks remain in the pursuit of knowledge. One of humanity's most ambitious endeavors, the journey of scientific discovery, is rarely without risk, and the LHC is no exception. Its operations delve into realms of physics where intuition no longer applies. For decades, physicists have attempted to comprehend the fundamental forces of nature: gravity, the weak nuclear force, electromagnetism, and the strong nuclear force, each of which plays a pivotal role in the structure of matter. The LHC has been instrumental in providing clues that bring us closer to a unified theory of everything, where all these forces might be reconciled under a single framework. As humanity continues to explore these frontiers, the nature of these experiments has raised important ethical considerations. Advances in particle physics may lead to unanticipated repercussions, not only for our planet but for the very fabric of reality. These are questions that are difficult to answer, requiring careful consideration of the broader implications of scientific advancement. The creation of exotic substances or the study of high-energy conditions could reveal unknown aspects of the universe, but they also carry the possibility of causing new phenomena that are difficult to predict. The search for scientific knowledge in these uncharted areas can inspire both excitement and fear. As discoveries unfold, humanity must grapple with the responsibility of ensuring that progress is governed by wisdom, prudence, and an understanding of potential consequences. Some argue that our understanding of quantum physics is still in its infancy, and the LHC's experiments in the realm of subatomic particles may one day lead to unforeseen discoveries with extensive repercussions. In the end, the LHC's experiments are designed to illuminate some of the most fundamental questions in physics. However, they also force us to confront a crucial aspect of human nature: the desire to push the boundaries of the known, often without fully appreciating the possible repercussions of such investigation. The hope is that the LHC's discoveries will improve our comprehension of the universe, but there will always be an element of uncertainty as we venture further into the unknown. As the LHC continues its groundbreaking work, it serves as a reminder of the interdependence between scientific discovery and societal responsibility. The experiments conducted at CERN could one day transform fields beyond physics, such as energy production, materials science, and medicine. By studying particles and their interactions, scientists may unlock new methods for harnessing energy or identifying novel substances that could revolutionize technology as we know it. However, the possibility of both extraordinary progress and unforeseen challenges is ever present. The delicate balance between exploring the unknown and managing inherent risks requires vigilance. As humanity looks to the future, it is crucial that we navigate this path with care, ensuring that we approach the universe's wonders with respect and humility, for the unknown consequences of our actions. Ultimately, the story of the Large Hadron Collider is not just a story of machines, particles, and theories, it is a story of human aspiration. It reflects our unyielding desire to comprehend where we come from, what we are made of, and what hidden forces shape the cosmos around us. This pursuit is as ancient as humanity itself, tracing back to the first moments when early humans gazed at the stars and wondered about their place in the vastness above. The LHC stands today as a modern temple of that same curiosity, built not of stone and myth, but of superconducting magnets, particle detectors, and the painstaking collaboration of thousands of scientists across the world. It reminds us that the pursuit of knowledge is a collective endeavor, transcending national borders, political differences, and even individual ambition. Yet, with such immense power to explore comes the solemn responsibility to ensure that discovery does not come at an irreversible cost. Transparency, ethical debate, and rigorous safety protocols must continue to guide scientific exploration, especially when it treads into realms where our predictive abilities grow uncertain. The importance of ongoing dialogue between scientists and the public cannot be overstated, for it is through openness and mutual understanding that fear is replaced by informed wonder. In the years to come, as the LHC is upgraded, new experiments proposed, and even larger colliders imagined, society will once again face questions about how far we are willing to push the boundaries of the known. Should we seek to recreate conditions even closer to the birth of the universe? Should we pursue the search for supersymmetry, extra dimensions, or unknown particles that could change our view of reality itself? These are not just technical or scientific questions, they are philosophical ones. They ask what it means to be human in a universe that may be far stranger and more complex than we ever dared to dream. They challenge us to accept uncertainty, to embrace the risk inherent in discovery, and to find meaning not only in the answers we uncover but also in the questions we dare to ask. As long as humanity continues to look upward and inward, questioning the nature of existence itself, places like CERN and machines like the LHC will stand as beacons of that enduring quest. Their legacy will not just be measured in data charts and scientific papers but in the expansion of human consciousness itself, the stretching of imagination, the breaking of old paradigms, and the forging of new ways of seeing and understanding the cosmos. And perhaps, as we peel back the layers of reality one by one, we will come closer to understanding not just the universe, but ourselves, fragile, curious beings standing at the edge of an infinite unknown, reaching ever forward into the stars.